every teacher you've had, there might be a different spin as to the way they do it. And I jumped right into kind of a more complicated version just because you should have a pretty good basis for how to solve a linear equation. I always start with cleaning it up. Cleaning it up means simplifying things, so distributing and combining like terms, kind of individually on each side. So here's my equal sign. There's really nothing to do on the right-hand side right away, but I definitely can clean up the left-hand side, so I'm going to distribute my 6, distribute my -2, then I like to combine like terms on my left-hand side, so that my x's will make 4x, my constants will make plus 26. So I haven't really begun the solving process yet. I was just cleaning things up. Now I'm going to start solving. Solving meaning, what am I going to do to both sides? So let's see who we want to hear from today. Alexa, are you aiming to get rid of this too?
Yeah.
If that was the only x in the problem, I would say yes, eventually we will do that. We would still have to get rid of that plus 20 first, though. But when you have x's on both sides, who can help her out? What should we do? Go ahead.
Subtract and then on the other side subtract.
Okay, so what do you want me to subtract from both sides?
Subtract the 2x
Yep.
by itself.
So your goal should be to get all of your x's consolidated together on one side. So for you, what's your first name? I'm sorry.
Haley.
For Haley, that was moving everything to the left-hand side. All of her x's are going to the left. You could have just as easily decided that all your x's were going to go to the right-hand side. But because she moved all of her x's to the left, this will be gone. She's probably going to move all of her constants to the right. So she's going to lose this 26 over here. So now we have 2x on the left equals -6 on the right, and divide both sides by 2, and of course x equals -3. Any questions? Okay. Number 2 has a fraction in it, and there's really two different ways. There's actually an entire chapter dedicated to solving rational or fractional types of equations. This one we don't really need those skills because we can first just, knowing that x plus 8 on a numerator is kind of in its own grouping, by being on that numerator together, there could just as well be parentheses around it. So we want to slowly kind of break this down. So if you've got a parentheses dividing by 2, you want to undo that division by 2 and multiply by 2. And then we have x plus 8 equals -12. And then we're just going to get rid of that 8. And x equals -20. Bless you. Yep.
Did you just flip the 6 over 1?
Cross multiply. Yep, that's one, and that's definitely a technique, and we'll do that. I would do that more often in the rational chapter, but yeah, that's fine. In number 3, Angela, what would you do first here? Very good. So 6x minus a 2x minus an 8, and also while you're at it on the right hand side, I assume you want to distribute that 3. 3x plus 6 plus x minus 5. We're going to clean up by combining 4x minus 8, and on the right hand side 4x plus 1. Alexa, I'm going to give you a chance to. Good, so she's going to bring all of her x's over to the left, and because she decided to do that, she's going to bring her constants over to the right. So we get 0x equals 9. What do you make of that? 0x is just 0. So does 0 equal 9? Obviously not. So there's, what did you say in Algebra 1 when you came up with something like this? What was your answer? Yep. Undefined, no solutions. Okay, so there is no solution to this. Another way of thinking about that, obviously, going back here, if that wasn't a 0, if that was like a 3, what do you do to both sides? Divide, right? And if you really wanted to stick with that strategy, if you divide both sides by 0, yes, anything divided by 0 is undefined. Still tells you that, hey, we have no solutions. There's no x value in the world that's going to make that true. Okay? So another, just, do you guys know what this means? Or this? That means both of those notations mean the empty set. So as you guys move more and more towards more advanced maths, you start to see more of this symbolic international kind of math language. And when you have no solutions, these two are really this is just a set notation. So the fact that it's a set and there's nothing in it tells you there are no solutions. And this little symbol there just means the empty set in math. So if you see that as a multiple choice solution, you know what that means, okay? On an open response, I'm pretty positive you can get away with any one of those 3 answers. On this next one, again, if we want to distribute first, it's going to give us 4x minus 1 on the left equals 16x minus 4 over 4. Nothing changes on the right. Now, if we wanted to, again, here we could cross multiply. We could put this over 1 and cross multiply. You'd have to obviously be careful when you're cross multiplying here. You'd have to make sure you distribute your 4 because you are multiplying a monomial by a binomial. Just to sort of stay consistent, and you'll see we'll have to do the same operation with the way I solved the previous one. I want to get rid of this divided by 4. So to undo dividing by 4, you multiply both sides by 4. Now on the right-hand side, that's just going to cancel that. On the left-hand side, if I'm multiplying what is there, which is a binomial, by 4, I'm going to need to insert my own set of parentheses so I don't forget to distribute, because that entire left side has to be multiplied by 4. The entire right side got multiplied by 4 as well, but it just canceled the denominator. So obviously the same thing results as if we had cross multiplied. And we could subtract 16x from both sides and add 4 to both sides, but you can kind of already see it here. Did I do something wrong? Oh.
Can you just divide the 4 and then look at that?
You can. Yep, I'll talk about that in a second. Thank you for bringing that up. But so we can kind of subtract that 16x over from both sides and add 4 to both sides. If we do that, we'll get 0 equals 0. But you can already see it. I mean, it's blatantly obvious. 16x minus 4 equaling 16x minus 4 is always going to happen, no matter what the x value is. So this is something where we have all solutions. Is that what you said? Infinite solutions? Infinite solutions is probably more common. So any x value, it's not as obvious when you first start. Oh gosh, how come I forgot your name again? What did it start with? Georgia. I'm glad Georgia said what she said. Going back to this step before I multiply both sides by 4, if you have a binomial and it nicely divides by 4, you can just, well, look at the original. You can just divide each piece by 4. So you'd have 4x minus 1. Okay? We did not do that up above because it would have given us 1/2 x plus 4, and I tend to stay away from fractions if I have that option. So if you see that and it divides out nicely, absolutely that's an option. In number 5 right here, it's an option. So we'll do what Georgia suggested. 4x plus 2 divided by 2, divide both terms by 2. So 4x cut in half is 2x. 2 divided by 2 is 1, plus your 8. And again, combining like terms gives us an infinite solutions. take a minute on your own if you haven't already done it. I know some people might have already gotten ahead and try 6, please. If you want to jump to the back, there's just 4 on there for you to start thinking about, kind of see if you think you might have any questions on any. So I don't love that you skip a step here. I'm not saying anything right around it, but I would prefer if you just let that unlock. And then on the right. So you are good. And so you need to grab it. When you're solving, you're trying to find the values for x. And so if someone said, what value of x make this true? How do you say undefined? So you say no. You say, talking to another human, you say no value for x. You would say no. Okay, so number 6 should be no solutions. Okay? When you distribute, just check your work if you got that wrong. We combine, get 6x minus 6 equals 6x minus 5. You should be able to see at this point. Now, again, if you want to take it a step further and subtract 6x from both sides and add 6 to both sides, or however you do it, and you get 0 equals 1, you're definitely able to go that far with it. But logically speaking, if you have an x and you multiply them both by 6, and from one of those products you subtract 6, and from the other product you subtract 5, there's no way they can be the same, right? There's no way that will be equal. So right here you should be able to tell that there are no solutions. Or we can do that. Okey-doke. For those of you who took a peek at the back, just so we can get right to the harder ones, was there anything on any of these that has you a little bit like, I'm not sure how I would do that? Go ahead.
For 9, would you just make the 3 as 6 and multiply it with 2 minus x times 2 as well?
Yep, right. So with fractional equations, and again, we're going to have an entire chapter dedicated to this. These are still technically linear, and we'll talk a little bit more about that in a second. But the denominators are all numbers. So where we have 2 fractions being added, yes, we want to get a common denominator. So between a 6 and a 3, that would need to become a 6. We multiply by 2, and obviously the numerator also has to be multiplied by 2. And again, that numerator is a binomial. The entire numerator, that entire binomial, has to be multiplied by 2. So I like to insert my own set of parentheses around that binomial so I don't forget to distribute. And then once that's done, I have 1 6 plus 4 minus 2x over 6. And now I can add those fractions. 1 plus 4 is 5 minus the 2x becomes my new numerator. And now I have a fraction on the left and a fraction on the right. And here I definitely would cross multiply. So when you multiply here, what do you get, Anne? 6 times x plus 1, you should be visualizing this. What would that become? Very good. And can you nail the second one for me, Ann? Very good. And then here we are. Get all of our x's on one side. I'm going to bring my negative 8x to the left. So that'll be gone. And then I'm going to bring my plus 6 to the right. So I have 14x equals 14 and x equals 1. Then obviously we should be checking all of our answers. I'm just not doing that for the sake of time to make sure we get through all these, but you would definitely want to check your answer. Okay? Anything else on the back that if people got started, maybe trip them up? Raise your hand if you finished 7, 8, and 10 already. What'd you get for 7?
For 7, I got 25 thirds.
X equals 25 thirds. All right, let's audit his work. Here we go. First step, Chris, what would you do? Okay, so what would that look like? Very nice. And what would my next step look like, Sierra? Very good. And my next step, Faye? Very good. And Eric? Perfect. And how did Corey do? Spot on, right? And that's what you'll see as your answer usually in Algebra 2. You're not going to see a decimal so much. Question? Yeah. Yeah. Something like this is 9 times out of 10 going to be a multiple choice. So obviously you could rewrite this as a mixed fraction. What would that be? A mixed fraction. How many times does 3 grow into 25? 8. That gets you to 24. So how many left over? 1 out of 3. So mixed fraction, yeah, that would probably be the second most prominent presentation of that answer. And then really the third would be 8.3 repeating. It's not, we really don't see them give us that decimal answer often. All right. Who else finished 8 or 10? What'd you get?
For 8, I had
No solutions. All right, let's audit her work. So, what's my first step going to look like, Elena?
multiply the x reciprocal times 2.
Okay, so just tell me what to write.
2x minus 2
Keep going.
plus 3 equals x minus 3x minus 3.
Very good. And Jack? What's my next step going to look like? There are? Oh, Jack. Birmingham.
Sorry, I was doing 10 earlier.
Just tell me what to write. That's fine.
2x plus 1 equals
Very good. The other Jack? Okay, so what did you do to both sides there so people can see that? Right, so we brought his constants over to the right, and he's going to bring his x's over to the left. So we have 4x equals negative 4. And our answer... That's okay. That's what'd you do wrong?
I just left it, but I think it's x equals negative 12.
Yeah, so you didn't realize one of those was a positive 2x versus the other one was a negative. So x equals negative 1 is correct. Good. And who finished 10? Why do I not remember your Bella? X equals negative 5. So Bella, did you get a common denominator on the left like you did the first time?
Yeah.
Okay, and that was 10. So this had to be multiplied by 2 and 2. So 6x over 10 minus, Oh, this one's going to cause some mistakes. Maybe you didn't make it. I'm not sure yet. But to make this a 10, multiply by 5 and 5. So did you keep the two fractions separate here at first?
Yeah, I did.
Okay, so minus, and you did 5x minus 15?
Yeah, and then I did, yeah.
Okay. The reason I say this is going to cause some mistakes, more so than the other fraction ones we've looked at, is because of that subtraction. It wouldn't be a big deal if we were subtracting a monomial, but because we are subtracting a binomial, a lot of people are going to screw up in forgetting to distribute that negative. So when you do that up top, it's going to be a 6x. This, again, because when they're in the numerator, they don't need their own set of parentheses, because just by being in the numerator, they kind of clump themselves together. I would say go ahead and insert parentheses around those binomials just to make you a little bit more likely to remember to distribute. So we're going to distribute that minus sign. That's going to be minus 5x plus a 15. And if you miss those parentheses or don't kind of process the fact that, hey, we're subtracting a binomial here, be careful, you would have had minus 5x minus 15. And again, that's over 10. That can become x plus 15. Oh, Bella, did you make that mistake? Oh. It is, unfortunately, the majority of people actually make the mistake, and the minority actually recognize it. It's that much of a common mistake. So if you just want to get ahead of that, and anytime you see binomials or polynomials in numerators or denominators, go ahead and throw parentheses around them, and you're just going to protect yourself a little bit more, hopefully. Now when we cross multiply, we get 3x plus, again, here we could throw them in there just to protect ourselves. 3x plus 45 equals 10x plus 20. Now, for the most part, you guys have been moving your x's over to the left. I, for one, do whatever I can to avoid a negative. You may be the same. So I here would choose to subtract the 3x actually to the right, and then subtract my 20 to the left. No matter which way you do it, it'll give you the right answer. I just prefer to avoid negatives. And divide both sides by 7, and we get x equals 25/7.